All right, people, here we are. Exponential functions. So we've talked about linear functions only so far. Here's another type of function. So just remind yourself a function is a relation where the x values do not repeat. A relation is a set of ordered pairs. So it passes the what? Vertical line test. So what I am endeavoring to do is to build a firm foundation so that everything that we go or everywhere that we go from there will be great. Okay, so this equation is simple. There are only two things, well, really three, I should say, and I do want you to say this because I don't talk about x, but x is usually time. Okay, all right, so exponential functions, there are three things that we need to be concerned about. The initial value, which is a, which is right here, a, your initial value. Your initial value is your y-intercept. Just remind yourself, y-intercept. All right, and b is your growth slash decay rate. Now b acts like a slope or a rate of change, but it's not necessarily linear because as we can look at these at these functions here, we should say functions. As we look at the functions, it's not a line because a line implies that it's a straight. These are curved. As we look at these functions, we can see that the rate of change is not constant, so it's not linear. So we call it the growth or decay rate, and usually x is your time. Usually in these scenarios, x represents your time. So we have one function over here, and I didn't write it, so you write it. I forgot to put it on. This is exponential growth. This is an exponential growth graph, and this is exponential decay. So what does it remind you of? Okay, it looks like it's going up to the left. Oh, Jesus, up to the right. Up to the right. So this reminds you of like a positive slope, right? So rises to the right, rises right. It kind of reminds you of a positive slope. So growth and positive have something in common. This one is looking like it's rising to the left, rising to the left, rising to the left. So decay and negative have something in common, right? This is rising to the left. Or you come up here, you're like, oh, I'm going down, 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 down. Oh, I'm coming up, 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 up. So that's how you can relate it to linear equations. And so we're going to go more in depth into the equation, but you must switch your mind that b is not the y-intercept. So don't get confused that, oh, that's the b, that's the y-intercept. No, this time a is the y-intercept. I know, I didn't make the math. I just teach it. Okay? So this is growth and this is decay. So let's look at the graphs of an exponential function. So we have y is equal to 2 to the x. Let's analyze this graph. Of course, yours is not colored, but this is the graph of y is equal 2 to the x. Oh, maybe I can pick colors that go with the equations. I should have made these the same color. I wasn't thinking about them. They're all blue. Would have been nice if I, made them red, purple, and black. All right. So y is equal to 2 to the x. So this is the graph of y is equal to 2 to the x. This is called the parent function. And somebody was like, parent, yeah, like your parent, where you start, where you originate from. You originate from your parents. So all exponential functions originate from this equation right here, y equals 2x. All linear functions originate from the parent function, y equals x. But this is where all exponential functions originate from. So when we look at the table, we can match the table like every point right here matches the point on the table. So -2, that's 0.25 right there. -1, 0.5 is right there. 0, 1, 1, 2, and then 2, 4. Okay? So when we look at the function, that's what we see. All right, so let's break this down. So y is equal to 2 to the x. So all linear functions are in the form of y is equal to a times b to the x. But some people will be like, but there's no a here. I see a b to the x, but I don't see an a. Well, a is our initial value, right? Initial value, or y-intercept. Y-intercept. Take a moment to write that down. That's our y-intercept. So we can look at the table and see what's the y-intercept. The y-intercept is when x is 0. So where x is 0, this is my y-intercept right here. Okay? So this is my y-intercept. This is my a. I know we're so used to saying b, but it's not this time. So it's right here, y'all. This is my a. So if my a is 1, why don't I see it in the equation? Aha. Aha. Because we know, and math competent people know, that 1 is always there. So this equation right here can be written, there's my little bully. He's going to show up from time to time because something's wrong with, I don't know. But yeah, we'll be pausing the video to getting him together. Oh, it might be her. There's some girls that bully people. You know, I know a few. Okay, so y is equal to 1 times 2 to the x. We can write that like that. But it's the same thing as y equals 2 to the x. Okay? Because 1 multiplied by anything is going to be itself. All right. So y equals 1 times 2 to the x. That's the way we write this exponential function. Okay, so to keep this video from being super long, but y'all need to get the foundation. So that means I start here. That's my 1, right? It's my start. And then I am saying that the growth rate, because these are rising to the right, they are rising to the right. So we have a growth rate rising to the right, rising to the right. So we're saying that our growth rate is 2. Okay, how can we see that? Well, it's like we always seen slope. Slope, it's not slope this time, Mr. O'Neill. You can call it rate of change. It's not necessarily slope. The growth rate can be seen on how the y's over the x's are increasing. So let's look at the table. So how do I get from 0.5? How does 2.25 become 0.5? Well, y'all, we can think we're adding 0.25 every time, but we're not. I shouldn't put this a right here. I should probably, I don't know, because I want to use this. So sorry. As we're going down, what's happening? We're not adding. We're doing what? We're multiplying. Okay? Hence this right here. So to find the growth rate, it looks like we're multiplying by what? Well, if you don't get the fractions, you can look at here. It looks like we're multiplying by 2. 2 each time. 2 each time. So the growth rate is 2. And we can see that because b represents the growth rate. That's 2 to the x. 2. And then the x's are increasing by 1. So the growth rate seems like we have to multiply, and that's what the equation implies. Your y-intercept multiplied by your growth rate to the x, or your decay rate, but all these are growth rates. Okay, so that's how I see that. I can also see it in the graph. If I look at how, as my x's increase, this is a 1 right here. They skip this. That's 2. This is a 3 right here. So as my x's increase by 1, what are my y's doing? They're growing by 2, a multiple of 2, a multiple of 2 each time. So I can see that in the graph. So that's where the equation comes from. All right, and so when I move on to the next one, let me see if I can find the purple. Yeah, I found the purple. Yeah. All right, so this equation is y is equal to 2 to the x plus 3. Okay, I know I'm shifting your mindset. I'm going slow because I want y'all to get it. Y is equal to 2 to the x plus 3. So where is my y-intercept? Well, according to this table, my y-intercept is at 4. And according to the graph, my y-intercept is right there at 4. How do we get 4? Well, we get 4, the y-intercept comes from when x is 0. So when I put 0 here, I'm just going to squeeze around here. 2 to the 0 plus 3 to the 0, we learned recently, is 1. So 1 plus 3 gives me 4. So at 0, 4, my y-intercept exists. Okay? And so what is this 3 doing? Well, according to the parent function, from the parent function right here, adding 3 seemed to shift the graph up 3. So that's 1, that's 2, that's 3. So adding 3 is shifting the graph up 3. But is 3 our y-intercept? No, it's not our y-intercept. It's important to know that 3 is not our y-intercept. 4 is our y-intercept because anything raised to the 0 power is 1. So this is no longer our y-intercept, but it's doing something to the graph. It seems like it's shifting the graph up 3 from our original parent function of 2x. So adding on 3 shifts the graph up 3. Okay, so we can check this by looking at our function rule. So we have 2 to the x plus 3. So when we're coming down, this I'll say, how do I want to say this? So the growth rate is being changed because I'm adding on 3. So I can't necessarily look at here and like see what the growth rate is. Can't do that. We'll have to use something like, we have linear regression. We will have to use exponential regression to figure out what this equation is. So we can't necessarily do our little trick over here that we did here because we're adding on 3, which is changing what this looks like. Okay, so that's not going to work. But we do need to understand the actual properties of this exponential function. So y is equal to 2x plus 3 is graphed here. So my growth rate is going to be still seen because at 1, so at 1 I have 5 and at 2 I have 7. So our growth rate has shifted simply because, well, our growth rate has shifted, but our graph has shifted because we have moved up 3. Okay? All right. If we take those 3 away, we'll honestly see the growth rate. That's where we'll see the growth rate. Okay, so I don't want to give you too much in the beginning, so let's move on to the other one. Y equals 2x minus 3. Y equals 2x minus 3. To the x. Y equals 2 to the x minus 3. I didn't say that right. All right. I didn't write down the other equation. Let me go back. So y equals 2 to the x plus 3. This still was our growth rate. This is still going to be our growth rate, which is our b. And then our a is actually 4 because it's 2 to the 0 plus 3. So our a is going to be 4. We don't see 4 in the equation, right? We don't see 4 in this equation. We see the b, and the 4 comes from setting your x to be 0, like we always do when we want to find the y-intercept. All right, let me get my voice together. It is early in the morning. I don't sound too enthused, so let me get myself together. All right, and the last equation, y equals 2 to the x minus 3. So again, here is our parent function. We start here. And so what does the 3 do? Well, it looks like it's shifting it down 3 because that's 1, that's 2, and that's 3. So it is. The adding on 3 shift the graph or the function up 3, subtracting 3 shifts it down 3. But notice it's still growing at the same growth rate. Okay? They're still growing at the same growth rate. All right? So we have y is equal to 2 to the x minus 3. This is still our b. I didn't say b over here, but we're going to say b right here. And so our a can only be found when we let x be 0. So we get 2 to the 0 minus 3 is equal to 1 minus 3, which gives us our negative 2. Y-intercept is right here. Okay? Y-intercept is right here. So if we take away these 3, if we take away 3 from all of this, we're going to end back up. If we take away the minus 3, and that means we add on 3, we end back up, we end back at, that's what I want to say, end back at our parent function. We add on 3, we end up at 0.5. Add on 3, we end up at 1. If we take these 3 away from over here that was added, we end up back at our parent function. So those are growth, okay? These are exponential growth functions. Why? Because it's rising to the right, rising to the right, rising to the right. Okay, I need you to get that. Make sure you understand that these are growth functions because they are rising to the right. All right, so let's look at when they don't rise right, when they rise left. So here is something that is very, very evident. The first function is y is equal to 1/2 to the x power. So why don't I have a negative sign? We're going to see this later, what the negative sign does. So in linear functions, when we have a negative sign, it flips it. So rises to the right, positive slope. Rising to the left will be a negative slope. But in exponential functions, what's flipping it is actually a number less than 1. Let's give that to you all before we go on to the discovery. So it seems like a decimal that is less than 1 is flipping this thing, because we had 2 and now we have 1/2. And so let's see why that's doing that. So again, let's deal with the parent function. Well, we don't have the parent function, but we have y equals 1/2 x. Y is equal to 1/2 to the x power. Okay, remember that we have to say everything, because if you just put 1 to the x power divided by 2, you're basically saying, hey, square that. You're not putting everything to the x power. So it needs to be in parentheses. I taught y'all that. Put it in parentheses. All right, so y is equal to 1/2 to the x power. So let's see what happens when we put in 0. When we put 0 in here, anything raised to the 0 power is what? 1. Anything raised to the 0 power is 1. So here is our wonderful y-intercept right there. And let's do some other math, because going back up here, I didn't really stress this too much, but I should have went over this. Let's look at the parent function and then I'll go back down. So going back up here, if I say 2 to the negative second power, yeah, I forgot about that part. So if I said, I'm gonna put it right here, 2 to the negative second power, that's 1 over 2 squared, which is 1/4. That's where this number comes from. I'll be right back. The bully is out to get me. All right, the bully is gone for a moment. I can get back to work. All right, so that's where this 1/4 comes from. Okay, that's exactly where that comes from, and that's 0.25. So that's what we're doing. And so when we go here, when we're saying 1/2, I'll put it right here, 1/2 to the negative second power, all of that in parentheses, I am saying flip the base, or, we could just flip the base and the exponent becomes positive. Flip the base of 1/2, which becomes 2, and the exponent becomes positive, which gives you a positive 2. And so 2 squared is 4. That's where this number comes from, right there. And I know we can distribute. We can get 1 over 2, negative 2, negative 2. Flip both bases. You come down here and square. You come down there and square. And that's going to give you 2 squared over 1 squared, which is 1, which ends up being 4 still. The bully, the bully, the bully. Bye, bully. So, I don't know if y'all's screen got brighter because I unplugged it. So I don't know if that happened or not. Okay, so now I'm just going through the same thing. I'm not going to spend a lot of time on this because it's the same concept, but just different numbers. So when we go to purple, we get y is equal to 1/2 to the x plus 3. Okay, that's what it is right now. I'm giving you a chance to write it down. And so when I put in 0 right here, because I don't have any room right there, I write it on top. 1/2 to the 0 power plus 3 is 1 plus 3, which gives me 4. Y-intercept is 4 right there. So if we understand that, if we put a fraction, if it raised it to a negative power, then the number is going to flip, and now the fraction becomes a whole number or an integer. and then we're squaring that integer. So that's why these numbers come out. So this is really right here 2 squared plus 3, which is 7. 4 plus 3 is 7. This is now 2 squared, 1 squared plus 3. Well, 2 to the first power, which is 2. 2 to the first power plus 3, which is 5. Then this becomes 0. And now it becomes 1 plus 3 is 4. And then now we have the positive. So now this one is saying 1/2 to the first power plus 3, which is 3.5. 1/2 squared plus 3, which is 1/4. So you get 3.25. So that's where those numbers are coming from. Okay? So it's the same concept. And then when you move on to the black graph, it's the same thing. It's the same concept. Notice that we're going to say 1 minus 3, which is going to give you -2. And we get y is equal to 1/2 to the x power minus 3. Notice that adding on 3, see how big this bad boy is? You're not too big. Adding on 3 shifts it up. Subtracting 3 shifts it down. Okay, down 3. And we're going to talk more about why it curves like this in just 1 minute. All right, so that's the gist of the exponential functions. So we are saying that if this number is a growth factor, it's going to be greater than 1. It's going to make more sense in a moment. If this number is less than 1, it's a decay factor. So negative signs do not change the rising to the left. The fractions less than 1 change it from rising to the left. Okay, we're gonna come back to this in a second. So let's review what we just went over. So why is this happening? So exponential growth is y is equal to a times b to the x. When b is greater than 1, you get a bigger number. So for instance, we just saw that the growth factor was 2. This was our parent function when we had y is equal to 2 to the x. You don't have to write this down. When we had y is equal to 2 to the x, we saw that, hey, you're going to be like 2 to the first power, 2 to the second power, 2 to the third power, 2 to the fourth power. So that number is going to get really big and is not growing at the same rate. Like you're doubling the number every time. And so that's the reason why we get this spike right here. One moment you're at 2 to the first power is 2. One moment you're at 4. Then you're at 8. Then you're at 16. Then you're at 32. You know, so it's going to grow rapidly fast in a short amount of time. That's why it's called exponential growth, because it's growing rapidly in a very short amount of time. At 4, 2 to the fourth power is 2 times 2, which is 4 times 2 is 8 times 2 is 16. At 4, you're already at 16. Like you started off at 1 over here, and now at 0, you're at 1. And now at 4, you're at 16. So the same is true for decay. A negative sign, we'll see in a second what a negative sign do. Some of y'all could just play with it and just say, oh, if I put a negative sign in front of here, what would your y's be? But a negative sign is not going to change this. Actual fraction is going to change it. A fraction where b is less than 1, a decay rate is going to change this. Because if I have y is equal to 1/2 x, what happens here is that 1/2 to the first power is 1/2, but 1/2 squared is 1/4. This number is getting small, and this number is getting small real quick. So when you get to like 4 over here, we're at 16. 4 is at 16 over here, but remember the negative power says flip the base, and the exponent becomes positive. I don't know what I just put there. It's supposed to be an S. Positive. I think I was saying positive in my head and I put a P. I do that from time to time. Like I mess up my words from time to time. All right. So flip the base and exponent becomes positive. So what used to be a really small number, when you flip that base, it's going to be a very large number. And so what happens over here when I say 1/2 to the fourth power, well, that's 1 over 16. That's a very small number, and it gets very small really quick. That's why it's called exponential decay. So that is what's happening. Is the reason why my graph is curved is, first of all, it's not a linear, it's not a constant rate of change, but it's growing rapidly because you're multiplying. You need to understand this right here. Okay, it's growing rapidly because you're multiplying. It's decaying rapidly because it's getting smaller a lot faster than normal because you are multiplying. All right, so that's the math behind this. And so we hinted at this. This is going to be on your quizzes. I'm just going to keep it flowing from here. And that'll be your last thing for today, because I want to solidify this in your brain. All right, so an exponential function is a function of the form of y is equal to a times b to the x. All right, we got that. If all of the x values in the table of values have a constant difference, meaning the x values being added or subtracted, and all the y values have a constant ratio this time means multiplication, then the table represents an exponential function. So these are going to be in the form of y is equal to a times b to the x, but your a is going to be a particular, well, I'm not gonna talk about it. All right, you'll see in a second. All right, so here is this table. Pay attention, y'all. All right, so if my x values are increasing or decreasing by a constant difference will be adding or subtracting. You can add on a negative, you can add on a positive, subtract a negative, you get a positive, subtract the positive, you get a negative, whatever. All right, so it looks like all of these are growing by 1. And then a constant ratio, which means multiplication. It looks like all of these are being multiplied by 3. So this will be exponential because it follows this rule. And if I wanted to write the equation, which I do want to write the equation because your quiz is going to ask you to write the equation and identify what's the growth rate and what's the decay rate and what's the initial value. If I wanted to write the equation, this is my initial value right here. So I would say that y is equal to a negative, I'm going to put it at -1 to start off with so y'all can see, a -1 times, this is my growth rate right here, times 3 to the x power. That would translate to be y is equal to negative on the outside, y'all. Negative times 3 to the x power. That's how we would write that. Okay? So our a initial value would be -1. Initial value right here would be -1. My b would be my growth rate of 3. How do you find the growth rate? You just look at how the y's are growing because the x's should be changing at a constant rate. So let's see if these next two tables are exponential. So let's do, usually it's y over x. We'll still do a y over x. All right, so are my y's growing at a constant ratio, which means multiplication? Okay, 0.5, 0.5, 0.5 to 1, 2, 4, 8. So it looks like we're multiplying by 2. Okay, if I want to figure out what the constant ratio is, take the next number, like here, take this 8 and divide it by the original. So 8 divided by 4 is 2. 4 divided by 2 is 2. 2 divided by 1 is 2. 1 divided by 1/2 is 2. That's how you find the constant ratio. If you want to see it's the same, take the next number and divide it by the previous. Okay? So we're multiplying by 2. Are we changing at a constant rate that is constant difference, which is adding or subtracting? Well, it looks like we're adding 1 all down here. So here, b is 2. What's my y-intercept, or my initial value, or my a? A is 2. So what will be my equation? My equation will be y is equal to 2 times 2 to the x power. Or you would see this as y is equal to 2 times 2 to the x power, which is more likely the way you would see it. Yes, that 2 needs to be in parentheses. Yes, it does. Yes, it does. Okay? Put them in parentheses. All right. So here we have from here to here, from here to here, from here to here, from here to here. So if you do what I just said a second ago, and you take 8 divided by 2, you get 4. 2 divided by 1/2, how many halves fit in 2? And 4, how many 0.125 is 4, is 4, is 4 all the way down, y'all. Forgot that 4. All right, and that's how I figure that out. I say 8 divided by 2, 2 divided by 0.5, And then these are constantly growing at 1, so my B is 4. I should probably start with my A. My A is 0.5. And so my equation is y is equal to 0.5 times 4 to the x power. So let's have a quick conversation. So this 2 represents my initial value. I meant to go back to lava. This 2 represents my initial value. This 2 represents my growth rate. Because B is greater than 1. I'll write this equation over here on the right. Because B is greater than 1, this is growth. All right? Because B is greater than 1. B is greater than 1. This would be a growth. So it'll come up like this. Probably not the best exponential function photo. And then we have y is equal to 0.5 times 4 to the x. Because B is greater than 1. This is growth. Okay? This is A. This is where we start. The 0.5 is where we start. But this is growth. So again, we'll have another exponential function rising to something like that. All right. So to make this less than 40 minutes, it says determine whether the table represents an exponential function. Explain why or why not. So it is clear that we see that, hey, it looks like all of these are growing by 1. If I do the previous one, 4 divided by 2 is 2. 8 divided by 4 is 2. 12 divided by 8. Oh, hold up. Hold up, buddy. 12 divided by 8, it's not 2. 12 divided by 8 is going to give you, 3 halves. This is not exponential. Not exponential. And why is it not exponential? Not a, I should write in complete sentences, sorry. Common ratio. Okay? And the reason why it's not common, because common means the same, y'all. You can't go from multiplying by 2, multiplying by 2, and then multiplying by 3 halves. It doesn't work like that. All right, so over here, my x's are, I should start with my x's, but I do. Adding by 1, and then if I do 4 divided by 1, that gives me 4. 9 divided by 4 gives me 9/4. Man, this don't work either. So this is not exponential. The ratio is not constant, or we can say common. I know y'all are writing with me. I'm gonna give y'all a chance to write it down. Okay, again, take the next one divided by the previous one, and that's how we can figure that out. All right, so I'm going to be here for another 2 minutes, 2 or 3 minutes, and then we're going to be done. It says determine whether each equation represents an exponential function. Well, if it represents an exponential function, everybody, it must be in the form of y is equal to a times b to the x. Can't deviate from that. So Is this equation in the form of y times b to the x? Well, a is your 3 initial value. 2 is your growth rate. Yes. Is this equation in the form of y times b to the x? Yes. A is 5, your initial value. B is 1.07. Yes. Is this one in a times b to the x? A is 4. B, hold up, and the x should be the exponent. The x should be the exponent. This should be the exponent. So no. Try to play us. You won't play us. And y equals 5x minus 8. If y'all don't know it's linear, you need to drop out of my class. I'm sorry. I love you, though. I love you as you leave. You'll come back because I can't let you go. We've been in this thing too long. No. Evaluate each function for the given value. So, y'all, this is basically simple stuff. You're going to basically say, hey, evaluate means to substitute. That's what it means. So, y is equal to 4 to the third power. 4 times 4 times 4, which is 64. So, y is equal to 64. Is this exponential? Yes. Why is it exponential? Because you got your a. What would your a be in here? 1. Your a will be 1. B is 4. All right. And let's look at the next one. F of x equal to 2 times 3 to the x power. 3 is 5. So, well, I just got a message that we're closed today. Yay and no, because, yeah, y'all gonna have to learn dividing the exponents, especially third block. Another time when I get back, I'm moving on. You won't need to be able to divide with this other stuff, but we have to come back to it. All this other crazy stuff, but whatever. We're closed, but it gives me a chance to do all this work. I need to get a chance to tell everybody I wasn't gonna be here all next week, so I'm gonna have to send out a message. I was gonna tell y'all today. You're gonna get your packet today, and yeah. So about that, it's not happening. All right, let's move on with our lives. So for the next one, we have f of x is equal to 2 times 3 to the x power. So basically, I'm saying 2 times 3 to the 5th power. 3 to the 5th power is 243. So I'm saying 2 times 243. And we get f of 5 is equal to 486. Please do the exponent first. Because that's what order operations tell you to do. You do that first. Please, no one say 2 times 3, which is 6, and do 6 to the 5th power. Please do not do that. Please don't do that. All right, and then the last one, we have h of t. So say h of 8 is equal to 60 times 1.07 to the 8th power. So if you do 1.07, of course you can put all this in your calculator and you'll be fine, but I'm just showing you the way you would do this. 1.07 to the 8th power is some long number. I'm not going to write it down. Multiply it by 60. Isn't it? Yeah, it's a long number. It's not like it's a big number. We're going to round to the nearest 10th point 1. So h of 8 is equal to 103.1. All right, so I made this shorter than 40 minutes, which, you know, it is what it is. It's the first lesson. And so let's review, because your quizzes are going to have this. You're going to have 2 times to do this on your quizzes. And, I mean, majority of them are going to be hundreds. But remember right here that if your b is greater than 1, you're going to have growth. It means it's going to be rising to the right. If your b is less than 1, that means you're going to have decay. That means it's going to be rising to the left. Okay? And if you understand that, and your a is your initial value, b is your growth rate or decay rate, then you're going to ace this. Okay? Look at the table. We can figure it out. Figure out the rate, the common ratio, and then find your initial value, and you have your equation, and you'll be fine. I have enjoyed this video. What are you doing? Get my stuff together now. That's what to call my sister. All right. This has been another Beast Mode production. This is Mr. O'Neal, and I'm out. I miss y'all.